for this one, as you can see, both sides have 4. One side has a 4 as a base, and the other one has an 8 as a base. Can I write 8 as a 4 to the power of something? No. So that means I have to change both bases. Okay? And what would that be? What would be my base? 2. So 2 to the power of 2. So that's 2 to the power of 2. Now, don't forget that I still have this whole power outside. Okay? So what I did is I changed my 4 to 2 to the power of 2. How about 8? 8 is 2 to the power of what? 3. And then to the power of 8x minus 2. Now what do I have to do here? And how would you do that? So you have to, what happens when I have power to the power?
You multiply.
Multiply. So I have to multiply that 2 by this, right? So that's going to be, I can simplify this to 2 to the power of 4 x minus 4, right? Because 2 times 2 gives me 4. And then this one, it's going to be 3 times 8x minus 2. Okay? I'm just going to write it like this for now, and then we will do the expanding. Okay?
Just look at 8x is 3s minus 2, right?
Sorry? Oh, it's 3x. Yep. I don't know where I'm getting made from. Wait, I want to check. Yeah. Multiply. Yeah, you have to keep your exponents. Right? To make it 4, it's 2 to the power of 2.
And to make it 8 is 2 to the power.
Okay. Now I can drop the base and just keep the exponent. So that will be 4x minus 4 equal 3x minus 2. So let's expand. That's 4x minus 16 equal to 9x minus 6. Bring the like terms to the same side, so I have negative 16 plus 6 equal to 9x, take away 4x. So brought the negative 6 over, brought the 4x. So that's going to give me negative 10 equals to 5x. Divide by 5, and then x equals negative 2. Okay, so the important part here was to make sure that the bases are the same, and then make sure that when you have power to the power, you are expanding, you're multiplying it.
Keep the exponents, please. That's what messed up.
What is it?
Keep the exponent.
Yes.
2 times 2.
Yes, you changed the 4 into 2, but you forgot to keep that power of 2.
Smells good. Smells so good. Food, that is.
They have a potluck.
Just me.
I know.
Me. Just me.
I just want to finish this question.
Finish it.
All right. So a cross-country skier forgets a mug of coffee and a muffin in a snowbag. That's me. Except the cross-country skier part. Their temperature in degrees Celsius after T minutes can be modeled by the formula T of coffee is equal to 81 times 3 to the power of negative 2T. And the temperature for the muffin is equal to 27 times 3 to the power of negative 1. Determine when the coffee cools to the same temperature as the muffin.
Say this quickly. Sound like regular? You put,
So you want to put the equations equal to each other? Is that what you're trying to tell me?
yes, ma'am.
And why is that? Because the question says determine when the coffee cools to the same temperature as the muffin.
So you want
Right.
to put them at the same time.
So they're equal to each other? Okay.
I think that.
So the question is asking you, determine when the T of the coffee is equal to the T of the muffin. Right? So, and I know the T of the coffee is 81 times 3 to the power of negative T. And the T of the muffin is 27 times 3 to the power of negative 1. So, what do you want to do here?
Isolate T.
But you can't isolate T unless you have the same base. So how can I make everything the same base?
Times the
Yeah,
thing.
we did 81 and found that, and now look at 27 multiple that.
You will want to put everything as the same base.
9.
So you can't multiply the 81 by the 3. Can I make 81 as a base of 3? 3 to the power of what gives me 81? 3 to the power of 4 times 3 to the power of negative 2t. Right? So you see what I did here is I changed my 81 as a base of 3. Right? 3 to the power of something. Because I have a base of 3 here. How about the 27? Can I write it as 3 to the power of something? Okay. I have the same base, and I'm multiplying. What do you do with the exponent?
Not even the same, so you can just times them.
Drop the base.
Okay, before I drop the base, I have to write it as the same base. Right? So, I have the same base, there is a multiplication. What do you do with the exponent? Add the exponent, thank you. So leave your base, add the exponent. So that's 4 minus 2t. Are we okay with this? On the right side, what do I do? Same thing. So keep your base as 3, add 3 minus 1, so that's 2. Now you can drop the base, right? Because now I have only one base on each side. Now I can just make my equations equal to each other.